Hello everyone, this is fifth tutorial for the fitting part. Okay, so in this tutorial I will quickly introduce you the Minuit class here, how to use the Minuit to do the fitting, and this is a very general class to no matter you have Gaussian fit or more than 2 dimensions, 4 dimensional fit here. Okay, it can fit up to 25 parameters, and there is some limitation in it. The first one is you have to set your data can be global access, be access in global scope here. All right, and this is a very important thing, and that's how it's worked for kind of a Fortune library in the TVirtualFitter here. And also you have to write your own chi-square function, and that would be used to be kind of minimizer, and it kind of can give you a reference or how the chi-square works, so you get the minimum point here. And if you have to use a limit on your variable, you have to note that because the TVirtualFitter class would transform your variable, um, especially somehow non-linear way. So it will become a nasty transformation. Sometimes it would cause the fit has some problem. So you should avoid to set the limit in your variable. So that means that your initial value should be more wiser. Okay. Um, so just a short note that TMINUT is you can have set several algorithms. So the migrate algorithm is used in by default, and in general is the best one, but is the weakness of this algorithm is that it really depends on the knowledge of first derivative here. Okay, so because this kind of a new way to do the fitting, so I will start by a very basic easy one. This is the Gaussian fit that we already did before. So I hope this would make you feel familiar with, and to I mean more easy to understand how to use this class here. And the good thing is the structure of the fitting procedure pretty fixed. So let's just start it here. Okay, so the first one, I go to this part here. I create a histogram, and note this histogram is global accessible here because I declare here. All right, that's just make it sure for the timing. Okay, so again, I create histogram and fit a Gaussian with 1000 count. Right? So we will fit this data here. So then I declare my fitter from the TVirtualFitter class. Okay, this takes some argument. The first argument is T object. You can put 0. It doesn't really matter in this case here. Actually, is I think it's some way to link it to the fortune. So I guess this is why you have to put 0 here. I'm not 100% sure, but you just put 0. Just remember put 0. And we have Gaussian function. So parameter, we have 3 parameter: amplitude, center, and sigma. So we put 3 here. So we have a virtual fictor. I call it Minuit. Okay, and it would fit 3 parameters. All right. So we have 3 parameters. So basically, you have to set parameter 3 times, and this is very important here. So the first parameter you can see this is the first parameter or zero index. And I call it A for amplitude. And I give some initial value because I can see the histogram. It's height around 30, and the second one is the kind of initial arrow. That's kind of initial looping step. It will change during the process, but you can set kind of reasonable one. And then this is the limit. The lower bound and the upper bound, if you both set 0, and you should try to set always 0, because when you set non-zero, then the TVirtualFitter, the Minuit, will have some difficulty to transform your variable here. Okay, do the same thing for second parameter, C center, and third one, sigma, and all this. I set the initial values, initial arrow, and no bound. Okay, so far so good. Okay, there is nothing with our data yet. Data will come over here. This is the set FCN. I think it stands for function. This function is for calculate the chi-square. Okay, so basically you just follow this procedure. You don't need to change anything. The only need to change is your own chi-square function. You can write what kind of name you can give it any kind of name. Just use a set function to put it here. Okay, and the rest part just some print and try to fit. And I was start talking about this chi-square function because it's really important to do the fitting part. Take in our data in this part as well. Okay, all right. Let's go here. So first, I have a function called my Gaussian here. This is function I really want to fit. And I will use this my Gaussian function put into the chi-square function, chi2 function here. And this function, chi2, has some fit format here. And there are several parameters don't use, not be used here. The thing we will use is the FVAL, final value, and a parameter here, and there are some parameter command off because they are not to be used. Okay, so you will try to think where our data come in. Okay, so think about a chi-square. To get a chi-square, you have to look over your old data point. So your data would be accessed here, and that's related to your chi-square value here. So actually, to do the calculation of the chi-square, you actually access two things. One is all your data point, and second, your function here. So in this case, I use histogram to store my data. So I have to loop through all the bins, okay, of the histogram. Excuse me. So I loop through the bin because just 1D. I first bin and the end bin here. Then I calculate the value in the bin content here. I get Y, and X will be the bin center, and I calculate the difference between the data and the function I have. Okay, so the X, okay, here is have to be kind of array like things because it's taken into pointer here. So the X is put in here. Okay, and PAR is for an argument list here. So you can define your variable list as this array here, put into the my Gaussian X here, and the code would be smart enough to change the parameter and to find out which one can minimize the chi-square. Okay, and this is a plus equal to. Don't just remember to use plus equal to. Sometimes we just use plus, then I'm wrong. Okay, you have to accumulate that. Okay, and finally you got the final value equal to chi-square, this value here. Okay, so this is a hard or maybe a new part for you to do the fitting here. You have to write your own chi-square. This gives you a lot of flexibility instead of just put into your function, because sometimes some section of your data would need to use another function. For example, this is maybe x greater than 0, another function, s less than 0, another function. But in this case, in this pathway, you can do this. In previous method, you don't have this flexibility, so this is rather good here. Okay, so everything just follow the thing here. Actually, you don't need to change much. So we already talked about here. Then we set the chi-square. This is the hardest part we already done. So everything should be ready to go. So then we have to set some command here. The way to set some command is to declare some argument list. Okay, so this means just set print. This whole block to set print here. Okay, so I don't like to print, so I set 0 here. This just one argument here, and here I start fitting. I have 2 arguments. The first argument 5,000. This is the number of function codes. The second argument is 0.01. This is tolerance here. So I put the argument list. I only use 2. Okay, again, this is similar to the code. This is the algorithm migrate 5,000.01 here. Okay, so you don't need to change this part so often. Maybe sometimes you want to change the tolerance or function number of function code here. Okay, so the fit will be done here, and some message will print out during this process. Then to get the fit result has certain fixed method here. So first you declare an array of 3. That will be 3 parameters. So this minimum parameters the double array here, and you call the get parameters here to assign each array. And also you can get array arrows. Okay, and to get chi-square or EDM, that means expected distance from median, and ERRDF and something like this, you have to use this function here, and then you can get a chi-square. Okay, so then finally we just put the parameters from the fitting result here back to F1. This is our function that we fit. Actually, it's this function. Okay, but this my Gaussian definition here is exactly here. Okay, so we see what it look like, and by code draw visualize the data. Okay, so now you know how it works. Then let's see the result. Like code part 1. Okay, so it look like this way. So this look pretty good, right? Let's see some result. Let's do it again. Okay, so we see here this give you some information about the initial condition here. You set the name A for amplitude 30, C 0 center, sigma is 1 here, and step size, this is 0.01 and no limit here, and this is the final result here, and chi-square. Okay, so basically there is this procedure is quite fixed. So the important thing is that you need to know how to write your own chi-square. Just just remember, you just need to look through all the data point and calculate the chi-square. So it basically is a loop here. Normally general have a loop, okay? And the data have to be globally accessible then. Okay, so this is the first part. Now I will show you more advanced example to fix a four-dimensional case, okay, using TVirtualFitter class. Okay, see you soon. Bye.